2023, 22.5 tons of trash were removed from Lady Bird Lake by a combination of city staff and volunteer. This problem is just the tip of the iceberg in terms of how much trash is present in Austin's bodies of water. There are tens of thousands of gallons of trash across Austin's 200 miles of creeks and streams, and more accumulates every year. The primary way that trash enters these sorts of waterways is through storm drains. It gets washed in from streets and other sources into creeks and streams. We suggest that by installing filters on storm drains, we can make it easier to collect this trash before it has a chance to enter streams and disperse, thus helping preserve Austin's beautiful landscape. Next slide. The amount of trash that enters the lakes is a large problem. 11 tons of trash are removed from Lady Bird Lake annually, and as before, there are tens of thousands of gallons of trash present in the creeks and streams. But the volume of trash is only part of the problem. It's the size of the trash that also contributes to making it difficult to clean up. Smaller pieces of trash have a tendency to disperse large distances because they float on water, such as like plastic water bottles and such. They can flow downstream very far away from where they entered, which means that to collect a small amount of small pieces of trash can take a disproportionately large amount of effort because you would have to travel many miles of creek downstream to collect it all. This is the problem that we aim to solve with our storm drains. As you can see here, this was data from a survey conducted at many different points along streams in Austin, where different points on the stream were categorized as being polluted by a specific type of trash. So minimal trash would be small plastic water bottle type size trash. Then there'd be apparent, abundant, and dense. As you can see, over half the locations surveyed were found to have minimal pollution. So that would be these aforementioned small pieces of trash, not clean, but minimally polluted. However, if you look at the total volume of trash present in these different creeks and streams, you can see that the minimal pollution actually makes up a very, very small portion of this. So that means even though you'd have to, if you wanted to pick up that very, very small minimal pollution, you'd have to traverse over half the area compared to the dense, which makes up less than a quarter, but makes up well over half, which is pollutes over less than a quarter of the different sites, but makes over half of the total volume.
So some of the benefits of putting filters on storm drains is that it could collect significant volumes of trash in one spot before they reach bodies of water. This addresses the problem of dispersion, greatly reducing the time required to clean up the trash. When trash is confined to one place, it can be collected by hand much easier than when it is dispersed over miles of creek. The Watershed Protection Department study states that some vegetation and creeks already act as natural filters, benefiting cleanup efforts by straining trash in specific locations and preventing dispersion of trash. By installing filters at storm drains, trash can be strained before it even enters the creek, preserving the natural beauty of Austin's water and making cleanup efforts easier. Adding filters to storm drains in Austin is a prime example of beneficence, the ethical imperative to do good to other people. Since the drains would reduce the amount of effort it takes to clean up litter, it would take less time and effort for city staff and volunteers to keep the creeks clean. Furthermore, keeping the bodies of water clean allows the city of Austin to keep its parks beautiful. Not only is it ecologically healthy to keep pollution out of the environment, but natural spaces can also be very beneficial to people's mental health. Adding filters to storm drains benefits not just people who keep the creeks clean, but also all the citizens of Austin who enjoy the city's natural waterways. Next slide, please. The diagram here demonstrates the implementation of the filter and how the pollution is prevented from entering the storm drain. The diagram also shows how without a filter, the pollution easily enters the storm drain through water flow. Stopping the pollution before it enters large bodies of water is crucial since it will make it much easier to keep the environment clean. Additionally, the storm drain will have smaller gaps in order to allow water and smaller plant matter to continue flowing through, and trash collection process is very easy is the trash will just be at the surface of the storm drain entrance and can be picked up by hand. It is important that the trash is cleaned up properly to prevent trash from accumulating outside of the storm drain. So volunteers are encouraged to clean these filters whenever the trash begins to build up. This can also be a great way to teach citizens of Austin of the dangers of pollution. And more specifically, school children can help volunteer to clean these storm drain filters with proper supervision from city or knowledgeable adults. Partnering with schools will ensure that future generations of people in Austin are aware of the dangers trash pollution can have on the environment, and it would raise awareness all throughout the city of the importance of keeping the environment clean.
We'd have two ways of evaluating how successful our endeavor would be with the storm drain filters. First, we have a big picture approach of looking at the total trash that ends up in the filters. We'd set a benchmark of 500 gallons per year. If that much gets caught in the storm drains, we'd consider that successful. That's equivalent to roughly 5% of the total amount of small trash present throughout Austin's lakes and bodies of water. We'd also measure a very specific location, the Lady Bird Lake annual cleanup. This is because there is, one of the studies we cited, it states that annually 11 tons of trash are removed from Lady Bird Lake. So we could compare past data to future data and say if over the following years we see a 2-ton annual reduction in the total amount of trash retrieved from Lady Bird Lake, we can consider the efforts of the storm drain successful in having prevented trash from ending up in that body of water.
So in summary, the proposal to install filters on storm drains in Austin promises enduring benefits for the city's environment and community. By curbing the dispersion and preserving the cleanliness of water bodies like Lady Bird Lake, these filters can work on a long-term solution to a persistent problem. The positive impact of this initiative cannot be overstated, as it not only relieves the strain on municipal resources and volunteer efforts, but also upholds the ethical imperative of beneficence by enhancing the well-being of both people and nature. To turn this vision into reality, we urgently call for funding and support from stakeholders who share our commitment to safeguarding Austin's natural beauty as well as ecological health. With collective action, we can make a lasting difference in the fight against litter pollution and ensure a brighter, cleaner future for generations to come. Thank you for listening.
Alrighty, I've got some questions for you guys. So the first one is, are there any groups in Austin who are doing something similar, and how will this be different?
Well, to answer this, there are some groups in Austin that are looking into protecting Austin's natural resources. For example, PODER, the People Organized in Defense of Earth and Her Resources, are an environmental stewardship project present in Austin. However, there are no groups that are specifically looking at putting filters on storm drains in terms of addressing the problem of litter in bodies of water. And so that would make our endeavor here unique.
Are there any groups who we would like to partner with to make this project bigger?
Yes, as mentioned before, PODER is a group that we would much like to collaborate with in terms of trying to make our project a reality. Because of their pre-existing nature as an environmental stewardship program, they would be helpful in helping us make this project a reality. And figuring out how to practically apply it beyond this sort of planning stage.
How often would the design need to be updated to keep them working at peak performance?
Someone else want to take the Q&A?
Yeah, I can answer this one. So the frequency of storm filter maintenance depends on various factors such as the type of filter used, the volume of stormwater runoff, and environmental conditions. Generally, regular inspection and cleaning are essential to ensure the optimal performance. Typically, storm filters may need to be inspected and maintained properly or quarterly or semi-annually to prevent clogging and maintain effectiveness. When looking at Lady Bird Lake, it would be essential to at least update the storm filters once every 2 weeks or every month to make sure it is working at its optimal capacity.
Are the filters easy to install? Could a group of volunteers install them, or should we hire professionals?
The ease of installation varies depending on the type and size of the storm filters. While some filters may be relatively straightforward to install and can be managed by trained volunteers under supervision, others may require specialized equipment and professional expertise. It's crucial to assess the specific requirements of each installation and determine whether volunteer efforts are sufficient or if professional assistance is necessary to ensure proper installation and functionality. The filters that are being used for this proposal and project will be easy to install with step-by-step instructions to make sure groups of volunteers or professionals can install or update them.
All right, last question. How easy would it be to expand this to other cities in Texas or even the world?
So expanding our storm filter initiative to other cities in Texas and beyond is both feasible and highly desirable. The underlying principles and technology can be adapted to suit different geographical and environmental contexts. By sharing our knowledge, experiences, and best practices, we can facilitate the replication of this model in other communities facing similar water pollution challenges. Collaboration with local stakeholders, government agencies, and environmental organizations will be essential to ensure successful implementation and scalability on a broader scale.
All right, I think that's it.